Okay, so good day everyone. So this time we're going to discuss about, of course, a topic about modeling of return of investment. No, so we have different actually return of investment methods. No, but of course, most commonly, business makes decision based on data. So without a clear understanding of the meaning and rules around this data, business decisions can be negatively affected. So data modeling is a time-proven method for understanding data, its interrelationship and its rules, and data management professionals have long understood the value of data modeling. However, business professionals often don't understand the value of data modeling. So this is true even though history has shown that omitting the data model produces an inferior database design that prolongs system development, causes increased maintenance, and reduced data quality. So the business can demonstrate management the return of investment of data modeling. So data modeling actually helps improve the quality of data, ensure the definition of high quality data requirements, and reduce development time, maintenance time, and redundancy, among other benefits. So the most conspicuous benefit for demonstrating the value of data modeling is the reduction of the cost maintenance or development it will enable. So most organizations spend actually 7 to 80% of their software budget on maintenance. So the value of data modeling can be demonstrated as an overall savings in maintenance or development cost. So viewed broadly across an organization's entire budget, and this can truly significant. So the value of data modeling can also be seen at the more detailed level by the saving it will provide for development tasks on a specific project. So additionally, its value can be determined by identifying specific benefits that can modeling provides and value, then quantifying those project by project. No? And data models can be reused in whole or in part of multiple projects which can result in significant savings of the organization. So to give us more details about the topic, let us welcome our presenter. Go ahead.
Good evening, sir. Good evening, classmate. I'm Jenny Sikikindao, and my assigned topic is about modeling investment returns. ROI, or the return on investment, is a financial ratio used to calculate the benefit an investor will receive in relation to their investment costs. Why use return on investment? Number 1, ROI can be used to assess the profitability and efficiency of an investment and thus make financial decisions. Number 2, ROI is easy to calculate and can be applied to all kinds of investments. Number 3, ROI helps determine which investment opportunities are preferable to others. ROI is a metric used to understand the profitability of an investment. ROI compares how much you paid for an investment to how much you earn to evaluate its efficiency. When you put money into an investment or a business endeavor, ROI helps you understand how much profit or loss your investment has earned. There are several versions of the ROI formula. The two most commonly used are ROI is equal to net income divided by cost of investment, or ROI is equal to investment gain divided by investment base. For instance, an investment with a profit of $100 and a cost of $100 would have a ROI of 1 or 100% when expressed as a percentage. What is the ROI formula? ROI is calculated by subtracting the initial value of the investment from the final value of the investment, which equal the net return, then dividing this new number, the net return, by the cost of investment, and finally multiplying it by 100. ROI is equal to gain from investment, or the current value of investment, minus cost of investment divided by cost of investment and multiplied by 100, where gain from investment is equal to money generated from the sale of the investment or the increase in value of the investment regardless of whether it is sold or not. Example: an investor purchased stock X on January 5, 2017 for $12.50 and sold it on August 24, 2017 for $15.20. Formula: ROI is equal to gain from investment minus cost of investment divided by cost of investment multiplied by 100. ROI is equal to $15.20 minus $12.50 divided by $12.50 and multiplied by 100. And the return on investment is 21.6%. Another example: Denzel purchases a house and lot for $250,000 in 2017. 5 years later, he sells it for $325,000. What is Denzel's return on investment? So return on investment is equal to profit divided by cost of investment multiplied by 100, where profit is equal to current value minus cost of investment. So Denzel sells the house for $325,000, which is the current value. Then he bought it for $250,000, which is the cost of investment. So $325,000 minus $250,000 divided by $250,000, which is the cost of investment, and multiplied by 100. So we get $75,000 as a profit, and then divide it by $250,000, which is the cost of investment, then multiply by 100. So the answer is 30% for 5 years. So Denzel gets 30% of his investment for 5 years. So now, how do we estimate its annual return on investment? So annual return on investment is equal to 30% divided by 5 years is equal to 6% per year. So the value of his house increases by 6%. And that is all. Thank you.
Okay, so this will be a direct computations actually of the ROI, no? But of course, when it comes to data modeling, no, because our main focus actually is the modeling, no, the data modeling available. But of course, that this will be an exact ROI computations, no. So how about your partner? Okay, so again, as I mentioned earlier, no, a while ago, no, I'll just simply give you the benefits, no, of having data modeling return on investment, no. Of course, information drives the business in its business decisions. So data modeling is critical to understand the information needed to make those decisions. Yet many business people don't understand the value it provides. Now, and of course, data modeling no cover the benefits covered improved data quality, no better business requirements definitions, a greater reuse of asset, reduce data movement, reduce maintenance, and accelerated development. And of course, we could able naman to provide different example of that. And actually, our presenter a while ago give us some computations of the return on investment. So we have a simple return on investment, no, wherein sabi nga ng presenter, return on investment is equal to net benefit divide net investment cost times 100. So that this will be the basic computations of a in computing the return on investment. Okay, so I just want to share a video presentation. No, most commonly, when it comes to model, no, because we're looking forward with the model of investment return or return on investment. I'll just want to give you a video presentations on how we'll be able to use the stochastic model. No? So this video is around 1 hour and 30 minutes. So if you have a questions related to this topic, do not hesitate to post in our chat box. But if you have some additional inputs, no, better for you to also chat to post in our chat box. Okay. So bear with this video and looking forward that you could able to get something from this video.
So today we would be starting with stochastic model of interest rates. Previously this chapter was in CT1, it was the 15th chapter. So first give the heading deterministic model. Deterministic model. A deterministic model is a model that provides an output based on one set of parameters and input variables. Next line. The deterministic approach can provide only a single fixed answer to a problem. Full stop. This answer will be correct only if this answer
Welcome to a definition of arithmetic return for investment modeling by FactorPad. I'm Paul, and here's how we'll do it. First, we'll start with a definition. Next, we'll visualize arithmetic return, and last, we'll demonstrate the calculation in Excel. Okay, let's start with a definition from our glossary. Arithmetic return is one of three methods for calculating return over multiple time periods. It is commonly used in forecasting applications. It is total arithmetic return when you add the returns together. And when you divide that total by the number of observations, it becomes average arithmetic return. This is time uncertain, meaning the order of returns does not matter. And see geometric return for the compounding method and also log return. And yes, you'll need to differentiate between these, so I think it'll help to get the visual. We're sitting here in Excel, and this is a snippet from our bootcamp course. Let's simplify this to 2 periods, but it could apply to 3 and beyond. Here we have 2 versions of arithmetic return. The arithmetic total return, sometimes just called arithmetic return, involves adding the returns together. And for the average, often called the arithmetic mean, take the total and divide by the number of observations. It's just the simple average we use every day, like 2 t-shirts selling for 24 is 12 per shirt. I put the total here in parentheses because that's similar to what you do in Excel. Let's peek at the chart because often the eye picks up something you might not see in a table. Okay, looks good. Let's walk through the total and average using 2 hypothetical stocks over 3 periods. ABC had returns of 10%, followed by minus 11%, then another positive 10%. XYZ had returns of 100%, followed by minus 50%, then it was flat. The total arithmetic return calculation is logical. You could add each one manually like this, or you could use the equals sum function with the range of returns in parentheses. We have observations here, and for the arithmetic average, you could do the division manually like this, or you could use the equals average function. You might ask, when would you choose the arithmetic method? It is the preferred method for risk studies and for forward-looking estimates. You can't predict the order of returns in the future. Instead, you predict averages over long periods of time, typically. The sentence earlier about time uncertain is meaningful now. Let me show you why. Geometric returns are more backward-looking when you know the order of returns like we did here, and it is more reflective of the true client experience over a historical period. And using the same data, but using geometric returns, look at the differences. 3% versus 2.5% and 16.67 versus 0%. To see why, follow the link at the end. Okay, that's it. There is a whole lot more to arithmetic returns. To learn more, I suggest diving right into the bootcamp for a classroom approach. There you basically recreate all of this during videos that range from 15 to 35 minutes, including a short lecture with guests, and we try to make it fun. It's on YouTube now with no sign up. Just navigate to the playlist or from factorpad.com. Oh, and here's the link to the video on geometric return. Click here to be alerted about new videos. Okay, thanks for your time today. I hope you had fun learning about arithmetic return.
Taste the
Okay, so again, a while ago, no, your classmate mentioned that she could able naman to play the presentation of your Madam presenter, no, the other presenter. So before paki-share muna ng screen para bago ko magano.
Modeling of investment return. What is
wait lang.
investment return? A mathematical formula that investors
Yan na ba yan? Wait lang, introduce ko muna ulit. Bagal lang net ko. Okay, so